factors. If it starts out like this, just for instance, if it started out like that, just for instance, and your factors are already set, then you're fine, you're good to go. But if you've got two different functions here, you have to be able to replace one of them. If it's already factored, then set them to 0 by all means. But if not, you have to be able to get one variable. So replace the sine squared with the one that you have to remember. Okay, replace that guy. And then be careful. Be careful what side of the equal sign you're on. Gather them together. And the factoring, we're not giving you really bad factoring. Most of them are just one set of factors. Even the ones with the 5 and the 7, just one set of factors. If you kind of think about it, we can't go too high on the factors because you're at like between 0 and 1 on the cosine curves. And tangent is the only one that can, and secant, your reciprocals can go a little higher. But you're still going to see 1, 2, radical 3. You're going to see the same thing over and over. Is everybody okay with this? Okay with all solutions? Make sure you give me this. Qualify it somewhere in the answer. Good? So you tell me if you have any issues. Okay. Again, you can move it to one side and do your perfect squares, or you can leave it like that. You can do your perfect squares this way. Tangent x plus 1, tangent x minus 1, and separate it that way. Or you can take the square root. Again, with the ones that are across from each other, do the plus n pi, where n is any integer. And make sure you go to this one here, and make sure it's checking this one. Then go to this one, and make sure it checks that one.
Would you deal with pi over plus n pi?
That's covered with our plus n pi.
So you have to write it down?
No. So if this is my pi over 4, and I add n pi, if I make this into fourths, I'm adding 4 pi. So 1 pi plus 4 pi gives me 5 pi over 4. Then I add it again, and I come back here.
Is the right to just write it all out?
If you wrote out all 4 plus 2n pi, it's not wrong. It's not wrong, of course, because it still comes back to those. But the ones that are diagonally across from each other, they're just 180 degrees across from each other. So just get this one and catch this one with an n pi. Get this one and catch this one with an n pi. Especially tangent. Your period for tangent is only pi. So you're going to see that whether we do all 4 quadrants or we just do the positives or the negatives. So say we just do the negatives. Because the period is pi, you're going to be pi apart from this all the time on tangent. Sine and cosine, this happens when you do a plus and minus sine and cosine as well. Okay. Use factoring or use your quadratic again. Again, you can set it up the same way. Tangent, again, is going to end up with a period of pi. So do your first quadrant plus n pi, do your second quadrant plus n pi. And this did ask for, well, something happened here. I wanted the bar. This guy did ask for the solutions between 0 and 4 pi. So once you find your all solutions, then just change this to the same denominator. So each time you're going to add 3 pi. This one's going to work the same. Change this to 3's as well, so you know where your stopping point is. Or just the fact that you have 4 in 2 pi will make you have 8 in 4 pi. And then each one gets a set of 4. Stop at that. And make sure you convert to the same denominator. And sometimes what happens is we end up reducing one of those angles, so the angles may not have the same denominator, so you may have to do that twice. We've seen that happen a couple of times where we reduce it. Questions on this? Jordan, can you see? It's kind of small. We just keep adding. We convert this to thirds, so we keep adding 3. So 1, add 3, 7, add 3, 10, 2, add 3, 5, add 3, 8, add 3, 11. And it should make sense. If you have 4 angles in 2 pi, you should have 8 angles in 4 pi. Because you did the plus or minus. Okay. Then we have a quadratic. Factor it. I think this was the same as number 1. I think this was the exact same as number 1, but you just had to find your solution from 0 to 4 pi. So I just, excuse me, I just took the shortcut and wrote with the cosines of x squared. This was the same exact, but this time I asked you to go from 0 to 4 pi. So convert your denominators again. If you're in thirds, convert everybody to thirds. So you're adding 6 each time. Remember when your cosines and your sines are zeros and ones, you're on a quadrant. Not so with tangent, because the cosine curves, their ranges are from -1 to +1. The tangents, their range is indefinite. So the tangent of 1 is your 45-degree angle. If you can kind of make sure that you get that part straight, you won't have as many problems, because a lot of kids go to try, oh, how am I going to make a triangle out of this? This is your quadrant angle. Graph your sine curve and your cosine curve. It makes a little bit more sense than going through the quadrants. Okay. Just the last one. All right, we've got cotangent in here. If you prefer, when you get down here, once you get down to the end, if you prefer to flip it, take its reciprocal to a tangent, the tangent is going to be the same thing. And they're both the same factor, so you only have to do it once. Not a lot of factors we can give you to make these work out nicely with 1s and radical 3s and 2s. We can't go too high on your factors, so it's kind of nice that way. We're not testing your factoring. We're pretty much testing, can you solve the equation and find the angles. Questions? Everybody can do these. And I think this is the last one. Again, you have 2 variables here. You can't change your tangent unless you want sine over cosine, which is going to take you a long time if you do this. It's doable. It's absolutely doable, but this is going to have to be replaced. Now, you start with your basic one. This is the one you just have to remember. If you want a tangent, tangent is sine over cosine. So this guy needs to be divided by a cosine. So therefore, divide everybody by cosine squared. It's an equation. So here's your identity. 1 plus tangent squared equals secant squared. So now you can take this out and replace it with this. Gather your like terms. This one was nice. Had a greatest common factor of tangent x. It's like an x squared plus x. If you struggle with the words, take them out for the time being. Factor out your x, never divide by x, and then put your tangent back in for x. Now, this one you have a number of choices. Tangent is 0 over here, at the 0. So we're just adding n pi. If you want to leave it as 0 pi plus n pi, if you want to just take this out and leave it as n pi, whichever you left it as, I'm fine with. And then this one is straight across from each other, so we do an n pi. Questions? Yes?
How would I solve that in quadratic form?
in the quadratic formula? Well, first you would have to take this out of here, right? You took it out, and you're left with this. So technically it's plus 0. So your A is 1, your B is 1, and your C is 0. And you can do it that way. And when you come down to the end, x equals, just say tangent x equals. Sometimes the simpler ones, because we're looking for them to be difficult, are harder to spot. Because we're looking for them to be like, okay, how am I going to factor this in? But, step back and take a look at it. That's why I said sometimes take the tangent out and put the x in, just for the time being to see what would I do with this guy. Oh, I would factor out an x. Oh, I'm going to factor out a tangent. Good? Does anybody have any questions on any of the other things that we did?